Hello all, this is Tanishq, the member of Fine Robotics Club of NIT Agartala, and I am here with one of the conceptual topic that is pulse width modulation. So, as the name suggests, I will go with this. Pulse means what is used to change, the changing signal. Width, that means the width of the anything. Like here, if we are dealing with pulse, then the width of the pulse. And modulation means changing something. That means modulating something, modulating the properties of the pulse here. So, before starting this topic as a whole, I would request you all to be with the video till the end if you want the conceptual clarity of this topic to the deep of its root. Now, I've introduced you what is pulse width modulation, that words itself, but what does it actually means in the technical term? Pulse width modulation is a technique used to encode the message into a pulsing signal. It PWM is widely used in various applications including power delivery, communication, and signal modulation. Now, basically, we used to have the signal in this type of form, the upper and the low and the high, which denotes the PWM. If we given if we are given with any signal, then at the output form we will get signals such as like this, which will have the low and the high form, and this signal is the PWM signal. At its core, PWM involves varying the width of the pulses in a pulse train. What does this pulse train means? What is train? Train is basically the segments of the coaches. So here it is, you can see here that this is in the form of the train, and we can modulate this width by varying the time or the amplitude domain. So here we can change the width of the pulse as per we want, and this modulation of pulse width allows for precise control over power. Why we need to change the width? We will come to that point also as the topic goes on. So let's move on. The two basic parameters which defines this PWM is, first one is the duty cycle and the second one is the frequency. What does the duty cycle means? The percentage of one period in which a signal or system is active. That means here you can see that from here to here it is the one wave, and in one wave or the one period, for how much time it is in the on state. On state means is the higher state, high value. So here you can see that for the 50% of the time it is in the on state in the one period. One period means the one wave. Here you can see from here to here. So it is in the on state for the 50% of the time. So this 50% is known as the duty percentage or the duty cycle. So percentage of time the cycle is in the on state in a given period is known as the duty cycle. Frequency is how many times the thing is occurring per second. You need to consider this per second, obviously. So I hope you would have been clear with this. This is not necessary that it will always be 50%. It depends for how much time this cycle is in on state. If it is 25% in the on state like this, then the duty cycle will be 25% only. So the duty cycle is determined by for the how much time the cycle is in the on state. I hope these two parameters would have been clear to you. This is the basic two parameters which defines the PWM, how it works. Now, how we can generate PWM signal? There are various methods to generate this, but the first one includes comparator. Now, from the name suggesting that comparator means comparing two things. Here we are dealing with the signals, then obviously we will deal with this comparison of two signals. Here you can see that at the positive terminal of this thing is basically the comparator. We are giving a triangular waveform, and at the negative terminal we are giving the V control signal, and we are getting such type of things here. Now how we are getting this the sawtooth waveforms. I did the name so because we have the tooth like this only. So do not need to go in the name of this. See here you can see that V control. This is the V control signal, and here it is the triangular waveform. Now when the V control signal is higher than the triangular waveform, then at the output side we are getting the low signal. Why is it so? Because what does the comparator do basically? If the negative, if we have the majority negative at the output side, then at the output we will get the low, and at the output if we have the positive greater than the negative value, then we will get higher state. So here you can see that V control is greater than the triangular waveform from this to this side. So that means the negative here, V control is at the negative side. So negative is more than the positive till this. So till this, since negative is more than the positive, we are getting the low value. After that, when the triangular input is greater than the V control, that means positive is greater than the negative side. So the positive concentration, you can say, for understanding it, is more than the negative. That's why we are getting high value. Similarly, you will proceed like this. So in this way, you can generate the PWM. Here it is the PWM signal, pulse width modulation. Second is the 555 timer IC. Now, it is the internal structure of that 555 timer IC, and I would explain you the concept how you are getting this. You no need to just remember this diagram, but just go through the concept I'm explaining you. Here it is the VCC is given to the pin number 8 and the 4 of the 555 timer IC. The three registers are connected in the series. That's why it is known as the 555 timer IC. Now by applying the KVL from here to here, you would obtain that this point has the voltage 2 by 3 VCC. This point has the voltage 1 by 3 VCC. Now, initially the capacitor is connected to the ground. So here the potential is 0 and here the potential is 0. Now come to this side. Here we have 0 potential, that means negative is less than the positive, because positive is at the 1 by 3 VCC and negative is at the low. Since positive is greater than the negative, so what does the comparator do? I have explained you on the previous slide that it will give the high value, and high value is the 1. Similarly, here the 0 is at the positive and at the negative we have 2 by 3 VCC. That means here the positive is less than the negative, so at the output we will get 0. Now at the R side we have 0, at the S side we have 1. So here you can see that what will be the output. This box is basically for remembering only, because you cannot directly go to this, that how we are getting this. So if the value of R is 1 and if the value of S is 0, okay, sorry, this one, the second one, if the value of R is 0 and the S value of S is 1, so at the output, that means the value of Q will be 1. That means at the output you will get the high value. As the this phenomena goes on, again you will have the voltage. And what does this Q dash do is, you can see that it is connected to this transistor. So when this Q dash is 0, here you can see that when Q is 1, then Q bar or Q bar will be 0. So if it is 0, then it is in the off state, and if it is in the off state, then as the previous goes on, this will again this charges, and at some point of time that this second value 2 will have the value greater than the 1 by 3 VCC. Similarly, by when this Q dash will be 1, then it is will be on. Then if it is on, then capacitor will discharge. Basically, the fundamental thing you have to take out from this here is, by varying the voltages over these terminals, and this voltages will be automatically varied because of the phenomena occurring here, charging and discharging of capacitor. By the varying of this voltage over these terminals, here you will get different outputs. Different output will be in the form of 0 and 1 only. And because of this different output or the different values of R and S, you will get different values of Q. And because of that different values of Q, you will get the structure or the waveform like this. And this is how you can generate PWM through the 555 timer IC. Okay, now I've explained you about this only in detail, not about the I'm not going to explain you about OPMP because this is the most advanced one. If you are understanding this, then understanding the function of OPMP and other analog components is very easy to get through. Okay, I hope this would have been clear to you till now. Now let's move to the further slide. Code on Arduino. Here you most of the people might not have been informed information about what Arduino is. So no need to worry about that. Here I have written code on Arduino only, not on other sites or the platform which you used to take. Because for most of the electronics things we used to code on the Arduino only. But it is not like that you cannot code on the VS Code or any other platform you used to supposed to. You can code on that. But for suppose if you are coding on writing this code on VS Code, then for getting the output in the form of wave, you need to have performing the Python code as per I know. But nothing to worry about that. Let's understood the code. Here it is PWM pin is 9. This is there are various pin used to be on the Arduino. It can so for generating it we are connecting to the 9. If you have the knowledge of the coding languages like C and C++, then here it is a void setup function creating which is used to create the output, and this is here we will put input for providing that output, getting that output. So it is the basic code that from which you can generate the PWM signal. Okay, no need to much go into that depth of this. Let's move to the next slide. Types of PWM. There are three types of PWM schemes. First one is the leading edge, second one the trailing edge, and the third one is the phase correct. Leading edge, here you can see the definition. Modulation starts with the leading edge of the pulse. Okay, so basically I will not go this line because you can go through on. Just understand the concept here. Leading edge means the pulse width start with the high and will end at the low. So this is leading edge. Trailing edge means it will start from the low and will end at the high. It can go further also, but the basic thing is it will start with the low and end at the high for the trailing edge. And for the leading edge, it will start from the high value and will end at the low value. And phase correct, obviously, the combination of both. That means it will be the in this the wave will be symmetrical with respect to this high value and with respect to this low value. It will be something like this, something like this will be there for the phase correct. So three types of phase PWM schemes are there. Now advantages of PWM. This is the most or at least the second most important part of this discussion. Application of PWM. Why we are even interested in this topic? Why we are learning in this topic? So basically the thing is that PWM uh, we will get to understand this in the next slide also where we will discuss about the advantages and disadvantages. But let us discuss here also. We are using PWM because the first and the most important thing is that it is power efficient. Power efficient, if it is power efficient, then what else we want? Because if it is power efficient, then obviously it will be energy efficient. That means energy utilizing. And in this world we need to have we are we are very good if we can utilize the energy. So the most important thing was that only that it is the power efficient. And the second one it is that it is linear in characteristics. Now I would explain you this both in detail. Suppose if you are sitting in a theater and you used to not just necessary that you are sitting in theater. If you are watching movie, then the movie used to be in continuous form. It is supposed to your eyes, but it is not like that. It is used to in the uh, packet form, or you can say it is not continuous but discrete. But it seems to your eyes that it is in the continuous form. It is due to the persistence of vision. You know well. Similarly, here also when PWM signal used to be in the low and the high state. So what happens generally, not generally, it used to happen that if it is in on state, suppose it is on state for the 50% of the time and off state for the 50% of the time. And suppose let's take the example of this LED dimmer or the LED of your house also you can take. So this mixture of on state and the off state, due to persistence of vision of your eyes, this two mixture will give you that the light is in the on state. And obviously, if we are mixing this two, then the light intensity will not be as like it is in the on state. It will be somehow dimmer. But the thing is that you will not get light in the off state. You will continuously get light in the on state, depending upon the duty cycle, obviously. If the duty cycle is more, then obviously the intensity of the light will be more, and for the more duration of time, you would be able to see the light continuously. So from here you can get it out that, or even though your cycle is in the on state for the 50% of the time, but you are getting the light till this time. So in this way you are utilizing the power. I think you are getting what I mean to say. The light is in the on state or the PW is in the on state for the 50% of the time, let's say. But you are taking giving having the output for over all this time. So basically in this way the power is being utilized and thus the energy. This is the just the example of the LED dimming. You can take any example for where this signal can be utilized, like the motor control. If we are switched on the motor, suppose, and if we are switching it off again, then it is not like that the motor will come down to the zero speed at that instant only. It will take some time. Here it how the PWM signal also works like. Okay, I think it is clear to you. So it can be used in LED dimming also. I've explained you audio signal by changing the amplitude to high and low. You can have the different types of sound and power delivery. The most efficient, the most important one, which I have explained you at the beginning only. So let's move further. Advantages and disadvantages. So I've told you that the most important advantages is that it is power efficient in power delivery. Flexibility in control. This flexibility in control is due to its linear characteristics. What is linear characteristics? What I'm saying this like, suppose if you are given an equation in the form of dy by dx, okay, and we are having some linear equation in this form only, dy by dx plus y dy by dx is equals to 0, something like that, and another equation which we have in the form of d2y by dx2 or dqy by dx3, something like that. So if you are very familiar with the mathematics, then not take this example only. You can take any other example like similar y is equals to x and another equation y is equals to x square plus something like 2x. So obviously the first equation, that y is equals to x something like this, will be easier to solve as compared to this y is equals to x square plus 2x. This is the most basic example I'm just taking as an example. So linear means this only, which is has the direct relation with the input and the output. And the PWM signal works on this only, that it has the linear characteristics. And most of the electronics devices and the circuits follow the linear system because it is easier to handle and does and PWM signal also has the linear characteristics. So since electronics devices need linear characteristics and PWM follows that, that's why it is easy to handle it. So that's why it is written flexibility in control applications and simple to implement in digital systems, obviously, because if the devices are requiring the linear characteristics and if you have linear characteristics only, so it will be easy to implement in the digital system. And also it has the value 0 and 1 only, so this is why it is written is it is easy to implement digital system and also in electronic system because it has the linear characteristics. Now all even though that we things have in this world have many advantages, but those things can have disadvantages also. And similarly, the PWM has, like, we are switching something off and on continuously, then obviously it will create high frequency if it is an on state and again off state, on state, again off state. Suppose in 1 second you have on and off state continuously several, like suppose you have, if you have this 100 times in 1 second only, so this would create a disturbance. Like, take an example, if you are sitting in a room and your friend is continuously clapping, so you would get disturbed. It is similarly occurring here. If you are switching something on and off continuously, then obviously there will be high frequency, and because of that high frequency generation, the electronic gadgets used to get disturbed, and this is the basic disadvantage of this PWM signal. Now PWM in practice, it is just basically the what we used to, where we used to have the use of PWM in our daily life, like in motor driver, in microcontroller, PWM controller, and adjusting the auto duty cycle. This I've explained you previously only, and real world example. Most familiar you are with the motor controller, because in a house you used to switch on and off the motor. So there you can see that if the motor is in the on state, then it will not just come to off state at that instant only. It used to come slowly. So here there you are utilizing the power and thus the energy. Okay, I hope I would have been clear to you. Now the most and the efficient is the conclusion part. Whatever you might not have get to the previous slides, you would get here. So just what we have learned till now is that PWM is signal has basically two output, low and the high. Okay. Now why we use PWM? Because of its most two advanced or the efficient properties. First one is the, it is the power efficient, and this what we want in our daily life, that everything should be power efficient. If it is power efficient, then obviously it will be energy efficient. And why it is power efficient? Because it do not lead to the wastage of energy. Okay, I've explained to you that if it is in on state and off state, then you will get the output even though it is in the off state due to persistence of vision or due to the rotatory motion also. There are many applications, physics applications. Thus it is power efficient, that then only we are using it. And the second one is, it is it has the linear characteristics. And if it is has the linear characteristics, then it is easy to implement it for any electronics devices, because linear circuits are more easy to solve than the complex one. Because we, for linear circuits, we have obviously the easy mathematics, we can obviously solve the complex one, but where we are getting easy, we used to do that only. And that's why for solving the circuits, we have more familiar or more easy to get the linear circuits, and PWM is also has also a linear characteristics. That's why we are using it. So why we are using PWM? Because it is power efficient and thus the energy. And second, it is the linear, it has the linear characteristics. And thus it is widely used technique in various application requirement efficient precise control of power and signal. I hope I would have been clear to you. Thank you. Have a nice day.